Hello dear all, welcome you all in my class of 3-dimensional geometry. Today in our lecture we are going to discuss about line in a plane. To understand line in a plane, some of the concepts that we must understand previously. Two-dimensional spaces and its equations. Equation of straight line in two-dimension figures and three-dimensional spaces and its coordinate systems. The objectives of today's lecture are visualization of line in a plane and its equations, direction ratios and direction cosines, distance between the 2 points in a plane, and the equation of line on a plane. Let us discuss about three-dimensional coordinate system. How we can understand three-dimensional coordinate system as a plane, like if you have some axes like x-axis, y-axis and z-axis respectively. So if you have some plane that comprises with y and z-axis, that will give you some yz plane. In a similar case, if I look at the plane that comprises with the two axes, namely x-axis and z-axis respectively, then in that case the plane comprising these two axes will give you xz plane. And in a similar way, the axis that comprises x-axis and y-axis is known as xy plane. So we now want to think about three-dimensional spaces. If you know about how to identify the points in three-dimensional spaces, we require three numerical values. The obvious way to make this association is to add new one axis, that is known as z-axis, or that will be all the negative axes comprising, that means on the back side of the pages, that is given in the figure here. So in this way you can also think about the negative x-axis, negative y-axis and negative z-axis also. How can I understand three-dimensional Cartesian system, that is called three-dimensional Cartesian coordinate system, which is formed by the points called the origin, and a basis consists of three mutually perpendicular vectors. Like if I think about from my right hand rule, if I look at this thing, that is known as that consisting of three things. That means if I think about the x-axis, y-axis and the z-axis, they all are actually perpendicular to each other. If I think here, you can say here that this page is completely this four finger comprising you some x-axis. Okay, that means some page outside the page, and this is your x-axis, this is your z-axis and this is your y-axis. So in this way, where these all the things are joined together, is known as origin. So I can give this point as the origin. Okay, so this is given as the origin, and all the points that is behind these positive x-axis, this is your positive y-axis, this is your negative y-axis, this is your positive z-axis, so this will be your negative z-axis. This will be a positive x-axis, then this will be your negative x-axis. Let us think the equation of plane in three-dimensional geometry, where we want to draw some line and where we want to understand my line. Okay, a plane is a flat two-dimensional surfaces that extend infinitely so far. A plane is two-dimensional analog of a point, zeroth dimension, a line, one dimension, and three-dimensional spaces. A plane in three-dimensional spaces has the equation ax plus by plus cz plus d is equals to 0. This is known as the general form of equation of plane where at least one of the numbers, either a, b, c, must be non-zero. A plane in three-dimensional coordinate space is determined by a point and a vector that is perpendicular to each other. What are direction cosines and direction ratios that are very helpful to understand the plane and the line? That means line on a plane. Suppose the directional cosines of a line, that means that directs something, or the cosines of the angles which the line makes with the positive direction of the coordinate axes. Consider a line OL. Consider a line OL, this is your O and this is your L, that is making some angle with x-axis as angle alpha and some angle with y-axis as beta and with z-axis as gamma, as in shown here as the figure. So thus the direction cosines are given by L is equals to cos alpha, M is equals to cos beta and N is equals to cos gamma. So these cosines of the angles found with their respective axes is known as direction cosines. Note that the line LO, or I can say OL also, the direction cosines will be minus L, minus M and minus N. That means this will defined as, if I am thinking about the vector LO and OL, they are completely reversed to each other. So the direction ratios are so I can say the direction ratios are simply a set of three numbers A, B and C. They are proportional to your direction cosines respectively. That is, I can say here that L by A is equals to M by B is equals to N by C. I can say that they must be equal to K times of, that is called only K. So in that case, L is directly proportional to A. That means K being some constant number or proportionality constant. So in this way, I can define your direction ratios that define with your line on a plane. Let us think about direction cosines in a plane. Some facts of direction cosines in a plane. The cosines of the angle made by line with the positive direction of coordinate axis. These are denoted by letter firstly L, M and N, and their values are cos alpha, cos beta and cos gamma respectively, where alpha, beta and gamma are the angle with the respective axes in the positive direction. For L, M and N, L square plus M square plus N square is equals to 1. That means I would like to say that the square of direction cosines and their sum is given by equals to 1. Direction cosine of line joining two points can be given by my equation, that is called some coordinates, that is given by x2 minus x1 divided by pq, y2 minus y1 by pq and z2 minus z1 by pq, where pq is the position vector. That means I can say that magnitude of your position vector, that is x2 minus x1 ka whole square plus y2 minus y1 ka whole square plus z2 minus z1 ka whole square inside a under root, that is given by some Euclidean norm. Let us discuss about direction ratios of a line. That means some facts on direction ratios also. How can I find the direction ratios? So direction ratios are the three numbers that are proportional to direction cosines that I discussed in our last slides. That was given by L by A is equals to M by B is equals to N by C, and that can be written as equals to some proportionality constant that is given by K. So L was directly proportional to A and M was directly proportional to B and N was directly proportional to C. If L, M and N are direction cosines and A, B and C are direction ratios. Then I can represent my direction cosines in terms of direction ratios given by the expression here as A by under root A square plus B square plus C square, and similarly M is equals to B by under root A square plus B square plus C square, and N is equals to C by under root A square plus B square plus C square. Direction ratios are the lines joining the points P and Q whose coordinates are given by x1, y1, z1 and x2, y2, z2 respectively. Then direction ratios are given by the modulus of x2 minus x1, modulus of y2 minus y1 and modulus of z2 minus z1. Let's have some analysis of line on a plane. The line is determined by a point and a direction. Thus, to find the equation representing the line in 3 dimensions, choose a point P0. I can choose a point P0 whose coordinates are given by x0, y0, z0 on a line, and a non-zero vector v parallel to the line. That means I can say that this is a v parallel to the line. Since any constant multiple of vector still points in the same direction, it seems reasonable that a point on the line can be found either starting at the point P0 on the line are following a constant multiple of vector v. So we can see the following figure here. So if I look at the position vector, so r0 is the position vector. If I think about the r0 is a position vector of point P0, then the line must be of the form r vector is equals to r0 plus t times of v vector. So since you know that r is a Cartesian form, I can write it as in the Cartesian form as x, y, z in 3-dimensional figure. r0 can be represented as x0, y0, z0, and your v is some a, b, c. Then the equation will be, you can put the values of your here r0 and v also, and just evaluate, and you can put the value of r also as x, y, z, and then equate their positions and equate their variables. So in that case you are getting some equation that is given by the equation of line on a plane, and is given by x minus x0 by a is equals to y minus y0 by b is equals to z minus z0 by c. Let's discuss with some examples on equation of line in a plane. Let's have a discuss with some questions. Find a vector equation and the parametric equations for the line that passes through the point 5, 1 and 3 and parallel to the vector 1 plus I plus 4j minus 2k. So here r0 means that means I can say that your position vector of your L line this is given as 5, 1, r, that is given by 5i plus j plus 3k, and you have a vector v that is given by I plus 4j minus 2k, that is given here, which is parallel to the vector. So the equation 1 becomes looking like r is equals to r0 plus v vector times t, that I told you in the last slide. So that means I can put all the values in terms of t. That means r will be equals to, that means adding my I vector with some I vector, j vector with some j vector, and k vector with some k vector. So in that case what is going to happen? Then 5 plus t times of I cap plus 1 plus 4 times of t into j cap plus 3 minus 2t, that means this 2 times of t into k cap. So from here I can say that how many parametric equations are there? There are 3 parametric equations that can be obtained by putting the value of r as x, y, z, and then in that case x is the component of I cap, that means I cap is a component of x-axis, so this will be equal to x, that means x equals to 5 plus t. J is a component of y-axis, that means y is equals to 1 plus 4t, and k is a component of z-axis, so I can say 3 minus 2t is equals to z. So this is why you are getting some equations, they are known as parametric equations. So choose a parameter. Parameter means what? Some family that can be discussed with some family for a family. So I can vary the value of t according to my need because it is a parameter. So by varying the parameter, let's take some parameter of value of t is equals to 1. So you are getting the value of x is equals to 6, y is equals to 5, and z is equals to 1. So the point on a line will be 6, 5, 1. Similarly, if I take the value of parameter as t is equals to -1, then also we are getting some other points that will be on the line of the plane. That is given as 4, 3, 5. The vector equation of the parametric equation on the line are not unique. Make sure this thing that according to our choice of parameter t, your equation of line will be varied. Okay, so if we change the point, that means what I am doing here, what I am talking about here is if we change the point or the parameter or choose a different parallel vector, then equation change. Here are some problems that you must study to understand this lecture very clearly in a very accurate way. So these problems will help you to understand this lecture very thoroughly and in a very efficient way. The first question is, find an equation of the line through 1, 0, 3 and 1, 2, 4. Here is another question. Find the value of a and c so that a, 1, c is on the line 0, 2, 3 and 2, 7, 5. Hope you understand this question how to find. Find the distance from 2 to 2. This is a coordinate, some point given the coordinate system in three-dimensional spaces, to the plane that is given by x plus y plus z is equals to -1. Another question is, find an equation of line through 1, 0, 3 and perpendicular to the plane x plus 2y minus z is equals to 1. Here is another question. Determine whether the line 1, 0, 2 plus t times of -1, -1, 2 and 4, 4, 2 plus t times of 2, 2 and -4 are parallel, intersect or neither. Okay, so you can understand by using these problems, by understanding these problems, by solving these problems very clearly and in a very efficient way. So thank you for joining my lecture.